In this video, I'm going to be teaching you how to do long division with polynomials and binomials. Now, if you don't know how to do normal long division, I've left a link to my video on long division in the description of this video. If you are familiar with it, then let's get right into it, okay? So we have x minus 1 as our divisor, but I just wrote x to the power of 1 just to make it clear, okay? Just that this x is to the power of 1. That'll be useful later. Okay, so just like normal long division, we have to divide x minus 1 into the first term. So to make it less complicated, all we're going to care about is the highest degree term, okay? So how many times does x go into 2x cubed? Or what is 2x cubed divided by x? Well, 2x cubed divided by x would be 2x squared, okay? So we're going to write 2x squared up here. And now, that was our divide. And now we're going to multiply 2x squared by this binomial, okay? So that'll give us 2x cubed minus 2x squared. Okay, just like normal long division. Now we subtract, okay? So we're going to subtract this binomial from the top binomial. We'll have 2x cubed minus 2x cubed, which is 0, so they cross out. Negative 3x squared minus negative 2x squared, so plus 2x squared, gives us negative x squared, okay? Now we bring down plus 8x, okay? And now we repeat. So how many times does x go into negative x squared? Negative x times. We'll write negative x, or if you like thinking about it this way, what is negative x squared divided by x? Negative x, okay? So what is negative x times this binomial? Well, that will be negative x squared plus x, because a negative times negative is a positive, okay? And now we subtract. So negative x squared minus negative x squared is 0, so they cancel out. Then 8x minus x is 7x. Then we bring down the negative 12. And for our last step, 7x divided by x is 7. So we can go plus 7. 7 times that is 7x minus 7. Okay, we're going to subtract this. 7x cancel out. Negative 12 minus negative 7 is negative 12 plus 7. So that's going to be negative 5. Okay, and now we're done because x does not go into 5 any whole number amount of times. Okay, so now we're left with negative 5. Now, is our remainder just 5? No. Since our divisor was x minus 1, our remainder is what we have left here, so negative 5 divided by x minus 1. Okay, so be careful. Your remainder isn't what you have left over. Your remainder is what you're left over divided by this number that's here. Okay, so now for our second example. This is a little more complicated because we have a coefficient here, but we're just going to follow the same rules. Now, we have to make sure that everything is in descending order. Now it is, but we're skipping a degree, right? We should have we don't have an x squared element right here. So we actually have to rewrite this to give us an x squared element. Okay, so I'm going to rewrite this as 2x plus 1 divided by 4x cubed plus 0x squared plus 9x minus 12. Now, I know that this looks very weird having a 0x squared element, but we need it as a placeholder since we don't already have an x squared element, all right? Okay, so now we will proceed. 4x cubed divided by 2x is 2x squared, okay? So 2x squared, and then we multiply 2x squared by this binomial. So 2x squared times 2x is 4x cubed plus 2x squared. And then we subtract, so these will cancel out, and then we'll have negative 2x squared. All right, and we bring down our plus 9x. Okay, negative 2x squared divided by 2x is negative x. Negative x times all this is going to give us negative 2x squared minus x. Okay, we subtract this whole thing, so negative minus a negative, it'll cancel out. And this will add, so we'll have plus 10x because we did 9x minus negative x or 9x plus x. Okay, then we bring down our negative 12. 10x divided by 2x is 5. So plus 5. Multiply 5 by this binomial, we have 10x plus 5. Subtract, these cancel out. Negative 12 minus 5 is a negative 17. Okay, so our remainder is not simply negative 17. Our remainder is negative 17 divided by 2x plus 1. Okay, this is how you do long division with binomials and polynomials.